Okay, we're on question 7 now of the what is a limit lesson. First thing it says is to sketch the piecewise function f at x equals, and then we have two branches, x squared when x is less than or equal to 1, and negative x plus 3 when x is greater than 1. So first of all, I would be seeing that 1's an important part. That's where my two branches are going to split off. X is less than or equal to 1. That means I'm allowed to put 1 in here. So at 1, my y value would be 1 squared, which is 1. So I'm going to put an open dot there, or sorry, closed dot there, because I'm allowed to equal 1. And then anything less than or equal to 1 is allowed for an x value as well. So I can put 0 in, getting me 0, negative 1 in, getting me 1 again, negative 2 in, getting me 4. And if you recognize x squared as a parabola, we can draw in this part of our curve. So up until positive 1, we've got this parabola here. Then when x is greater than 1, strictly greater than 1, but that does mean it can be 1.00000001. So if we pretend to put 1 in, if we pretend to put 1 in, we'll have this negative out front. 1 plus 3, we would get 2, but there'd have to be an open dot there because we're really not allowed to put 1 into the function. Very, very close to 1, infinitely close to 1, but really not allowed to be 1. But after 1, we're fine. So we could put 2 in, for instance, and that would give us negative 2 plus 3, which is 1. We could put 3 in. We'd have negative 3 plus 3, which would be 0. And we can see that this f at x equals negative x plus 3 does look like a line with a slope of negative 1. So we can use that slope to continue figuring out points. And then using a ruler, hopefully draw in that part of the line there, that part of our f at x. So we have drawn the piecewise function f at x equals x squared when x is less than or equal to 1, and negative x plus 3 when x is greater than 1. So there's the first part, is to draw this piecewise function, which we did. One piece, another piece. Now we're determining each limit if it exists. So again, if you want to pause and try it on your own and then see if you get the correct answers, go ahead. So first they're asking for the limit as x approaches negative 1 from the left. So as we approach negative 1 from the left, these are our corresponding values on the curve. Our curve is approaching this value, positive 1. Negative 1 from the right, and then the same branch of the curve, and our curve is also again approaching positive 1. So the limit as x approaches negative 1 is positive 1. The limit from the left and the limit from the right are equal. Limit as x approaches 1 from the left. So as we approach 1 from the left, our curve, we would be on still this branch of the function, approaching this value here of 1 again. And as we approach 1 from the right, corresponding values are on this branch of the curve now, and we'd be approaching this hole at 2. And since the limit from the left and the limit from the right aren't equal, the limit as x approaches 1 does not exist. And that's the end of example 7.